let's continue the origin of soils. So, natural soil deposition. There are three types. The first one is granular soil, fine grained soil, and organic soil. So, what is mean by granular soils? Soils which is in the form of one by one particle, like this is one, two, which is not bonded with each other. So, in the form of grain, as I discussed in the previous video, that particles or grain means individual particles. So this is in the form of single particle. They have no bond with each other. So it is called what? Granular soil, or it is also called cohesionless soil. It is very important. What does mean by cohesionless soil? Some of the time it is called what? Adhesion. Adhesion means when the soil particles they are loose and do not stick together. They rely on friction between the particle for strength, not interbonding. What does it mean? This is, for example, soil particles. So the particles, I just make it exaggerated to zoom in. This is particle 1 and 2. They have no bond between each other. Okay, so how can they take load? They take the load, for example, this is 1 and this is 2. The load is coming from the top. So this is the contact area between these two particles. So the contact area when the loads comes from the top, so they are lap on each other or sleep in each other. So they take the load as a friction. What does it mean friction? This is, let me clear, this is one rock and this is another one. So you can see here there is roughness between the contact area of these two particles. So when the load is coming from the top, so this roughness of this contact area show resistance to each other. There is no bond between the two particles, but they can transfer the load from one to another by mean of what? By mean of friction. So this type of soil is called what? Cohesiveness or granular soils. Like you can see the sand or gravels. You can see in the sands when you take it in the how your hand and put it down. So slowly and gradually, like this is the soil particle sand in your hand, and you are put it down. So these all saints all fall down one by one, not all together. So it's mean there is no bond between the two consecutive particles. So that's why it is fallen down one by one. So this type of soil in which there is no bonds between two consecutive or two particles and they take load by mean of friction. So that type of soil is called what? Granular soils. Granular means grain means individual one particle, or cohesionless soil, and some of the time it is called adhesion. Understand? The another one is fine grained soils. It is cohesive. Cohesive means what? If the particle is very fine, you can see the particles are very small, and I would like to zoom this area exaggerated. So these are the particles, they have the bond with each other by mean of water. So you can see here the clay or silt, these are very fine in particle size and they have a bond between each other by mean of water or by mean of any minerals which is present in the soil. So the bond which, if the particles have a bond and take the load by mean of this bond, so that type of soil is called what? Fine grained soil or cohesive soil. The third one is organic soil. As I told you guys, the organic soil means what? Organics means plant or animal. So if the soil which is been made by the decomposition of plants, the due to animals, like for example, if the animals which has been died and buried in the soil for thousands of years, so the all the organs of the animal is mixed with soil. So that type of soil is called what? Organic soil. So you can see here the peat or muck. So this type of soil is called what? Organic soil. So these are the three types of soil which is on the basis of what? On the basis of different organisms. Now we are discussing some of the basic property of soil particles, which already discussed in the previous semester in concrete technology. Soil grain have different shape that are somewhat difficult to quantify. Shape means shekels, so you can see it is subangular. I will just make it clearly. there are two types, which is based on the texture. So it is the texture of the outermost surface of the soil grain. It is polish. So if it is polished, there are two gravel. This is another one gravel, A1 and 2. So their contact area both are polished. So when the load is coming from the top, so it can move very easily because there is no interlocking between the two particles. The surface of both the particles are polished. So what is mean by angularity? Angularity means roughness. Like these are one particle and this one is another particle. So you can see at the surface there is roughness. So here is subangular. It's mean there is a little bit angular and little bit it is smooth. What is full angular means? Angular means that all the edges are very sharp. This is sub round. You can see it is round at the surface, and somehow it is. You can see here it is angular. But rounded means what? It is in the all the edges are very rounded. Elongated means what? If the length is more as compared to its thickness. What is mean by flakiness? If the thickness is more as compared to its length. So these all properties we already discussed in the concrete. The another property is size. Size means in simple we can say how much it is big or small. So now you can say this is the whole soil and I zoom in or exaggerated this portion. These are the particle of size of clay and this is a particle of silt and this is sand. So you can see here from this graph the particle of soil is very small as compared to the silt and sand. So grain size simply means how big or small the particle size. Our soil is made of a teeny pieces. This you can see. This each one particle is called what? Particle. This each small piece is called particle. Some of the time it is called grain and also some of the time it is called sediment. We already discussed it, which are not perfectly round, but they have a regular shape. It doesn't mean that all the particles are exactly what round. They have some of the irregularity as well. Usually describe them by their diameter size. So how can we classify this type of soil that it is clay, silt, and sand? So it is on the basis of the size. This is for example sieve numbers. So we will see in the next slides if the particle size less than 0.002 millimeters, so it is considered what? Clay. And that if it is between 0.002 to 0.075, 0.002 to 0.075 mm. So this type of soil is called what? Silt. So this is the classification of soil on the basis of different size, which we can do by what? By sieve analysis and hydrometer. We can see in the next slide. So you can see there are different sizes again. If the size is less than 0.02 mm, so it is clay. Clay, if it is between 0.02 and 0.075 silt. This range is sand, more than this is gravel, in between this it is cobble, it is more than 300 mm, so it is called what? Boulders. Why is grain size important? So it is very good question. So the grain size affects soil behavior in various ways, crucial for civil and geotechnical engineering. The first one is strength. What does mean by strength? As we discussed in the previous one, then there are two types of material. One is cohesionless and then another one is cohesive. So the cohesionless means they have the bonds. This is particle 1, this is particle 2. They have the bonds between, they have no bonds between the particles, but they can check the load by mean of friction. So if the material is more rough, so it's mean they have more. Let me clarify. This is particle 1 and this is particle 2. And this is the contact area and it is rough. So if the material is more rough, outer surface area is more rough, so it's mean their bond is more good. Bond shears means they have more interlocking. If the interlocking is more, so they can resist more loading. For the fine grains, what we say is for the cohesive materials, they have the bonds with each other. They can resist the load by mean of bond. And the non-cohesive, like what, like sand and gravel, they can take the load by mean of what? Friction. The silt and clay, they take the load by mean of bonding between the particles. Deformation, this is the second form. Deformations means change in shape or change in form. So fine grain size are more susceptible to consolidation and plastic deformation under loads, whereas coarse soils deform less are more stable under structural load. For example, this is the course when the load is applied over there, so it is a very less chances to deform its shape. What does mean by deformation? Deformation means this is the soil particles. When, for example, 10 kg loads comes over there, so its shape is changed from one to another, or if it is brittle, so it is break down into two. So it is the change in shape, in change in the original shape. So it is called deformation. So the fine grain has less deformation or more deformation as compared to the coarse grain soil. The another one is permeability. Permeability is simple means the flow of water inside the soil. So if the material in the coarse grain soil, if the size is bigger, so it's mean there is more gap between the particle. If the gaps between the particles more, so the water can flow very easily. So it's means bigger size, more is the permeability. Same, for example, if this is glass A, this is another one glass A and B. Here I put it the boulders big and it is open from the bottom. Also, it is open from the bottom. And here I put it a sand of very small particle. So I put it about 1 liter water here and 1 liter water here. So I will receive water in this container very fastly, maybe in 5 seconds, and here I receive the waters maybe in 30 seconds. Why the further is flow? Uh, why the water take more time here? Because here the particle size is small. When the particle size is small, so the gaps between the particles, which is called voids, the voids is small. So if the voids is small, so the flow of water is very less. So that's why it is come very less. So is mean permeability in simple means the flow of water in the soil particles. So if the soil particles are large, the flow of water is what? Large, or the permeability is large. Grain size distribution. So what does it mean, grain size distribution? This we already discussed in the concrete technology sieve analysis. So grain means each particle, size mean how much it is big or small. A distribution means to taksim divide, either it is big or small. So grain GST is determine the particle size of particle in soil expressed by percentage of total dry weight. So there are two tests which is very necessary to understand this. If the particle size is more than 0.075 mm, so it's mean like sieve number 200, sieve number 200, which is 0.025 mm. So above this, if the size particle more than 0.075 mm, so we use what? Sieve analysis test. If the size particle is less than 0.075, it is less than 0.075 mm. So then we use what? We use hydrometer analysis. So you should memorize this. Okay, I skipped the sieve analysis test. We already discussed this in the previous semester. So if you have any questions, you can ask me in personal or direct. So I would like to start. These are the three very important terminologies which will be used in this whole subject. It is D10, D30, and D60. What does it mean? For example, from the sieve analysis, we take a soil sample of 1000 gram. These are the sieve size in mm. These are the mass retained. These are the cumulatives. What is mean by cumulative? 0 plus 0. 0, 0 plus 100, it is 100, 100 plus 200, 300. So you already know about these cumulatives, and these are the final passing. So once we calculated or once we prepare this table, after that we should to look for the percentage passing. So here you can say 10% passing. What does it mean? There is a term D10. D10 means that what is the particle size. Here D10 is equal to 0.30. It means that 10% of the total sample having size 0.03 mm or less than 0.03 mm. For example, how much it is 1000 gram? In 1000 gram, 10% of the soil particle having size 0.03 mm or less than 0.3 mm. This is the, for example, let me clarify, this is sieve number, for example, 0.30. So it's mean when I put it here, how much? 100 gram, like it meant 100 gram. So in 100 gram, through sieve number 0.30, how much? 10 gram is passed here. So the 10 grams, it is equal to 0.30 or less than 0.30. So the 10 means the 10 is equal to 0.30 means that 10% of the particle having size 0.3 or less than 0.3 mm. Same for the D30. D30 means that 30% of the particle having size 0.6 or less than 0.6. And what does it mean by D60? That 60% of the total particle having size equal to 1.18 or less than 1.18. So here also the D10 you should to memorize. D10, it is also called what? The it is also called what? The effective size. The parameter is the diameter in the particle distribution curve corresponding to sieve number, sorry, 10% finals, or the particle diameter at which 10% of the soil by weight is fine. So it will be very clear from the table. You can see here. So here it is the, from the sieve analysis we can make this graph. Okay, this is the percentage finer and this is the particle size or diameter. So you can see here it is 0, it is 10, 20, it is 30, 40, and it is 56, it is 70, 80, and this is 90. This is percentage pass or percentage final. So if we are interested in what? In D10. So it's mean 10%. I should make a straight line, sorry for the line, where it strike with this graph where it is at that point I move down here. So it's mean our particle D10 is equal to this value. It may be 0.12 or any value. So it's mean D10 is equal to 0.12. Same for the D30. It's mean 30% is passing. Make a line where the graph is strike. At that point, you should to move down straightly, and that is your value for the D30. Then there are two properties. One is uniformity coefficient, which is denoted by Cu. What does it mean? It's mean there is a simple formula for it. D60 divided by D10. You already know D60 means what? The particle size, the percentage passing. If this is the 60% of the material is passing, if the value is 0.3, for example, it's mean that 60% of the material having size 0.3 or less. So the 60 divided by the 10, it's Cu. The 10 is effective size. What does it mean? For example, if you divide, this is the example, the 30, 60 is equal to 0.6. What does it mean? That 60% of the material having size equal or less than 0.6 millimeter, and same here, 10% of the material having size equal to 0.2 or less than 0.2. So just put this both of the values in the above equation, so it will give you 0.3. So now what does it mean by 0.3? We use this for the purpose to check that our soil is what? Uniform graded, well graded, or gap graded. So how can we check it? If the value of Cu is less than 4. If Cu is less than 4, so that type of soil is called what? It is uniform. Uniform means that most of the particles have a same size. Like these are the particles maybe 19, 20, 18, 19, 20, 18. So it is close to each other that most of the particles are of same size. If the particle, if the Cu value is more than 4, so it is called well graded. Well graded made in the soil in which all are different sizes are present. So these are bigger, smaller, and medium sizes are present. So these all are present. So it means there is less voids. Is the lights or the gaps between the soil is less. So it means it has good strength. So how can we differentiate that our soil is uniform or well graded? So we can easily find by uniformity coefficient, and it will give us that our soil is well graded or it is uh, uniform. Here is another parameter which is called coefficient of gradation. Is used same to tell us about the how much the particle is big or small. So this is called denoted by Cc, and this is the formula d30 square divided by d60 multiplied by d10. And if, how can you classify if the Cc value is between 1 and 3, so it will be considered well graded. Other than this, so it is considered what? Poorly graded. For example, it is 0, 4, 5, 6, any value other than 1, 2, 3. So it will be considered what? Poorly graded. For example, we have the value for D60, D30, D60, and D10. So when we put it in the equation, it gives us the value 0.75. So the range is 1 to 3. If it is between 1 to 3, so it is well graded. If it is not between 1 to 3, so it will considered poorly graded. So you see it is less than 1, so it is considered poorly graded or not well graded type of soil.